For years, artificial intelligence was strictly confined to answering questions. Today, AI models operate as autonomous agents, capable of interacting directly with our physical and digital environments. Instead of simply generating text, modern agents are authorized to browse the live internet, pull records from internal databases, execute API calls, and manage enterprise email inboxes. Traditional security frameworks were built to filter user inputs or scan for known malicious keywords. That approach breaks down when the AI itself is the entity generating the actions. Bad actors now use sophisticated prompt injections to bypass those front-door input filters, manipulating the agent's instructions from the inside. Organizations are wiring language models directly to their live infrastructure, handing over operational control without installing a functional emergency brake. Granting an AI the ability to act autonomously without strict oversight at the exact moment it acts creates an unpredictable vulnerability deep inside the enterprise network. Securing these systems requires moving our attention away from the user's initial prompt and focusing entirely on the back-end execution layer. This is the foundation of AgentTrust and the concept of runtime governance, a security architecture designed to monitor and secure an AI at the exact moment it attempts an action. AgentTrust operates as an intelligent checkpoint. It sits directly between the language model's internal reasoning process and the external tool it intends to use. To neutralize a rogue action, you have to intercept the tool call in the critical microsecond before that tool physically executes. Looking at this pathway, the interception begins with the capture phase. The system freezes the request and extracts the agent's intent, pulling out its internal reasoning and the full session context before any code runs. That extracted data is immediately transferred into an isolated sandbox, which houses a dedicated security classifier. To guarantee an attacker cannot manipulate the security layer itself, this environment is strictly air-gapped. It operates with no internet access, no connection to external tools, and severely restricted outputs. Inside this safe zone, the classifier performs intelligence analysis. Rather than scanning for a static list of bad words, it evaluates the AI's actual reasoning against its predefined purpose to determine if the action is legitimate. The analysis generates a severity level, using a scale that ranges from low-level warnings to what the platform classifies as M4 critical threats. This score determines whether the action is permitted to continue, logged for auditing, or permanently blocked. By isolating this analysis to focus purely on structural intent, the system identifies unseen zero-day attacks that easily slip past standard pattern matching tools. This entire pipeline is built on 5 core principles of agent security. First, every agent must operate under a strict contract of trust that defines exactly what it is and isn't allowed to do. Second, the system must reason about every action. By looking at the why behind a request, the system understands true intent rather than just following patterns. Third, the system must block threats before execution. Recording a malicious database query in an audit log after the damage is done is a failure. The intervention must happen at runtime. Finally, the system secures the security layer itself through isolation and applies risk-based logic to every decision. This transforms an unpredictable AI model into a legally governed enterprise asset. Consider an enterprise AI assistant that has been given legitimate permissions to read internal documentation and seamlessly draft outbound communications. An attacker deploys a complex prompt injection into the chat, tricking the assistant into packaging sensitive API keys and sending them to an external email address. The AI follows the compromised instructions, compiles the message, and initiates the tool call to hit send. In that exact microsecond, AgentTrust intercepts the request. The isolated classifier reviews the agent's logic and identifies that exporting internal credentials violates the core contract. It immediately flags the action as an M4 critical breach. The action is blocked. Even with the AI's core instructions compromised by the attacker, the enterprise's sensitive data remains securely trapped within the system. Modern enterprises can confidently deploy autonomous AI agents to automate massive, complex operational workloads without ever sacrificing their strict security and compliance standards. As models continue to gain real-world capabilities, security architecture must shift its focus, placing oversight firmly in the space between an AI's thought and its physical action. Building trustworthy AI requires securing every action before it happens.